My name is Sheherbanu. My roll number is 16TE04. Today our topic of discussion is synthesis and decomposition, and second is common decomposition. This is a signal. Synthesis is the process of combining signal through scaling and addition. If I combine this signal, I get this by synthesis. Decomposition is inverse of synthesis, means breaking signal into two or more of its additive components. These are its additive components. Common decompositions are: first is impulse decomposition. There are 5 decomposition: impulse decomposition, step decomposition, even odd decomposition, interlaced decomposition, and one more. First is impulse decomposition. In impulse decomposition, n sample signals are converted into n spikes, and its advantages include: it looks at the signal one point at a time, only one point. The second is step decomposition. In step decomposition, n sample signal is converted into n steps. Its advantages include: it characterizes signal by the difference between adjacent samples. Even odd decomposition, signal is converted into even symmetry, divided into even symmetry and odd symmetry. In even symmetry, x of e of n is equal to x of n plus x of n minus n divided by 2. The signal we obtained is this. What is produced? It produces mirror image about y-axis. This is signal and its mirror image about y-axis. Second is odd. X of O into n is equal to x of n minus n divided by 2 here, plus x of n minus 2 here, minus. What we obtain from this, it flips about the origin. You can see that this is this signal and it is flip about origin, that is inverted. Its advantages include: it is used in important part in DSP called circular system, and it is a valid decomposition because even and odd parts are combined to reconstruct the original signal. For this interlaced decomposition, in this signal is divided into even sample signal and odd sample signal. For example, this is the signal given: x of n is equal to 1 2 3 4 5 6. This is 0 index 1 2 3 minus 1 minus 2. For x of odd, we consider the even values 0 0 2 0 4 0 6, and for even we consider odd value 0. Its advantages include basis for extremely important algorithm in DSP called FFT, fast Fourier transform. And the fifth is Fourier decomposition. In Fourier decomposition, signal is divided into signal waves, means half sine wave plus half cosine wave, and its advantages include: it is used in Fourier analysis, Laplace transform and Z transform. Second is wide variety of signals are created from superimposed signals. For example, audio signal. Linear system respond to sinusoid in a unique way, i.e. sinusoid input always result in sinusoidal output. Input, when we give input, we obtain output. For example, if we give input as sine wave, we also obtain sine wave, but the difference is in amplitude and phase. Next, what are the alternatives to linearity? If non-linearity is small enough, ignore it. If system can be approximated as linear, means if the linearity is not too much large, we can ignore it. And second is consider small amplitude of signal. So linearity, so non-linearity decrease. And third point is that when we multiply two signal uh, by convolution, for example, a of n is equal to b of n into c of n, then this is non-linearity. Multiplication result in non-linearity because power increase by power is in scale. This can be sorted out if we apply logarithm formula of addition to these multiplicative values. Log of an is equal to log of b of n plus log of c of n. So it is converted into linear signal. This is all from this lecture.